Okay, so let's start with a question that it sounds really simple at first, but the more you think about it, the more it might actually just break your brain a little bit.
Oh, I love those kinds of questions.
Right. So when you think of a number, let's say the number 17, what do you actually see in your head?
Well, for most people, I mean, it's just a symbol. It's a jagged line for the 1 and a little hook for the 7.
Hmm.
Or maybe, if you're a really visual person, you see 17 apples sitting on a table. It's static. It's just kind of there.
Exactly. It's a label, right? A label we stick on reality so we can count things. But what if that is completely wrong?
And that is the big what if we are dealing with today.
Yeah, what if a number isn't just a static label, but an actual dynamic living structure, like something with a heartbeat, a rhythm, and a really specific anatomy?
If you're going down that road, then you're stepping straight into the world of what the source material calls the Logosphere.
And that brings us to today's deep dive into the source material. We're looking at a really fascinating and honestly, a pretty intense stack of documents today.
Very intense. We're talking about some heavily rigorous mathematical and philosophical texts centered on the work of an author named Dato.
Yeah, these are absolutely not your standard high school math
That's
textbooks.
all.
We're talking about papers with titles like Nuclear Stratification, Hexad Rhythms, and this whole unified theory that claims to connect really simple arithmetic like 1, 2, 3 to incredibly complex wave mechanics.
And the generation of prime numbers, which is huge. And what's really compelling here is the rigor of it all. The source material goes out of its way to emphasize that this isn't just philosophical musing. It's not poetry.
Right, they use the term extremal strictness.
Exactly. We are looking at theorems proved with extremal strictness, scaling from basic combinatorics all the way up to something called homotopy type theory. So it's very grounded in high-level proof.
So our mission for this deep dive is to try and unpack this unified theory for you. We're going to look at how the numbers 2 and 3 are basically the DNA of the universe.
And why waves naturally have 6 phases instead of the usual 2 we think about.
Right. And then how colliding those rhythms might actually be the exact mechanism that creates prime numbers.
It's a massive paradigm shift. It's really about moving from viewing mathematics as this static, flat painting to seeing it as a kinematic, moving, breathing machine.
Okay, so let's just unpack this right from the foundation. The documents start with this concept called Theorem 3, which, I mean, it sounds a bit like a movie sequel, but it's actually about the core building blocks of every number.
Yeah, Theorem 3 is the absolute bedrock here.
Mm.
It states that any number greater than or equal to 2 can be expressed purely through 2s and 3s. The formula given is simply 2a plus 3b.
So you're saying no matter how incredibly huge the number is, like a million, a billion, whatever, you can build it entirely out of just two types of blocks. It's like if I have a giant pile of 2-stud Lego bricks and 3-stud Lego bricks, I can build literally any structure.
That is a perfect analogy. And in Dato's theory, that isn't just some fun mathematical trick. This combination of 2s and 3s is what the source calls the core, or the nucleus of the number.
The core.
Right. The texts argue that 2 and 3 aren't just arbitrary digits we use to count. They are the actual operators of generation, like the primary colors of mathematics. But that is really just the starting point, because then the theory introduces this concept of nuclear stratification.
I have to say, I love that name, nuclear stratification. It sounds like a geology term.
It does, and it is kind of like geology, but for numbers. The formula evolves to describe the entire anatomy of a number. It becomes n equals 2a plus 3b plus the sum of r plus delta.
Okay, wait, that looks a little terrifying on paper.
It's really not as bad as it looks.
Let's break it down piece by piece. So we have the core, the 2a plus 3b part. That's the heavy gravitational center of the number. What is the rest of it? What is the sum of r?
So that sum of r part represents what Dato calls the shell. This shell is made up of unique prime numbers that are greater than or equal to 5. And the key word to remember here is unique.
Okay, unique primes.
Right. These primes are essentially the harmonics that give any specific number its unique identity. If you think about it like sound, the core of 2s and 3s is your fundamental frequency. It's that deep bass note holding everything down.
Oh, I see. And the shell is the overtones.
Exactly. The trebles and mids that let you know if you're hearing a piano playing that note or a violin.
That makes so much sense. So the shell gives the number its specific flavor. But then you have that little symbol hanging out at the very end of the formula, the delta. What does that do?
The delta is the gap. The source calls it the closure. It's always a tiny number 0 1, 2, 3, or 4 that just fills the final tiny space between that core and shell structure and the actual number itself. It seals the whole thing shut.
Wow, so you have this dense gravitational center made of 2s and 3s, and then this harmonic shell of distinct primes swirling around it, and finally a tiny little remainder to cap it all off.
Yes.
That feels way less like a math equation and much more like the structure of an atom.
And that is exactly the intended visualization. The text explicitly describes numbers as breathing systems. The core provides the base rhythm, and the shell provides the intricate harmonic details. A number is definitely not just a point sitting on a flat line. It's a dynamic system with internal moving parts.
To really prove this, the sources use the number 17 as a specific case study, which made me wonder, why 17? Is there something inherently special about that specific number?
17 is actually a perfect case study for what they call a node. If you look at its stratification, 17 is a place where the rhythm of the core is almost completely saturated. You can write it simply as 2 times 7 plus 3 times 1.
Okay, basic arithmetic there. 14 plus 3 equals 17.
Right. But look at the actual structure. The harmonic shell is minimal in this case. In this framework, 17 represents a limit rhythm or an assembly point. Because the core rhythm is so dominant in 17, it acts as a massive structural anchor in the system.
It's so wild to think of 17 that way, not just as one more than 16, but as this highly specific structural node where these deep rhythmic forces perfectly balance out.
And that is the fundamental shift in perspective the author wants you to make. You have to stop seeing a number line as just a row of isolated points. You start seeing the Logosphere, a spherical space where numbers are entirely defined by their internal vibration and pressure.
Well, speaking of vibration, that actually leads us right into the next big chunk of this stack of documents, which is waves. Now, I always thought I basically understood how waves work.
All people do.
You go up, you go down, 2 parts, or maybe 3 if you count that center line in the middle.
Sure, that is the classical intuition we all learned. We see that familiar shape on a screen, and we count the bumps. Up, down. But the source material presents a theorem on the phase structure of a sine wave that completely upends that standard view.
Right, the text talks about a hexadal rhythm, and hexadal means 6. How in the world do we get to 6 distinct phases in a simple up and down wave?
The source breaks this down using a strict proof that actually goes through 5 distinct levels of mathematical rigor. But for our purposes, let's just stick to the topology, the basic connectivity of it. Think about one single full cycle of a wave. What are the actual physical elements there?
Well, you have a peak at the top and a trough at the bottom, so that's 2.
Yes, and you also have the zero crossings.
Yeah.
The nodes where the wave actually intersects the center line.
Okay, let me visualize that.
Yeah.
There's the start, then the middle where it comes back down across the line, and then the end where it comes back up and finishes the loop. So that makes 3 nodes.
Exactly. You have 2 crests and 3 nodes. Now here is where the math gets really elegant. A phase isn't just a static point in space. It's a state that is defined by its position and its direction.
Position and direction.
Right. At those nodes we just counted, you can be at the 0 line going up, or you can be at the 0 line going down.
Oh, okay, I see it now. So the 0 crossing right at the start is 0 going up, and that 0 crossing right in the middle is 0 going down.
Yes.
Physically, those are totally different mechanical experiences. Like, if you were a surfer riding that wave, those 2 spots would feel completely different.
That's a great way to put it. And the sources do the math on this structure. 3 nodes multiplied by 2 possible directions equals 6 distinct phases. This is the hexadal rhythm.
So a wave isn't just a simple binary up and down thing at all. It's actually a very specific 6-step dance.
It is. And here's where it gets fascinating on a philosophical level. The text goes on to discuss the theorem on the impossibility of a harmonic on 3.
Right. This was the part that argued you literally cannot have a stable wave with only 3 phases. But why not? 3 seems like such a good, solid number. Start, middle, end. A triangle. It's a strong shape.
A triangle is structurally strong, yes, but it doesn't roll. It doesn't flow. The number 3 represents a dynamic act. It's the launch, the peak, and the initial fall. But crucially, it does not close the loop. If a system only has 3 phases, it cannot return to its origin while still preserving its momentum and direction. You essentially just crash.
Because you haven't done the work of the return trip.
Exactly. To have a stable, recurring cycle, a living wave, essentially, you must have that return path. You need the dip below the line and the recovery back up. You need all 6 steps to survive.
That makes perfect sense. So the number 3 is the action, but the number 6 is the completed cycle.
Precisely. The text says 3 is the kinetic act, but 6 is the complete cycle. And this distinction is absolutely crucial. because it sets up the exact mechanical reason for how the universe generates brand new numbers.
Okay, here's where it gets really interesting. Let's unpack the half-wave theorem, because the sources frame this event as almost a violent collision of geometries.
It is absolutely a collision. The core question posed here is, what physically happens when you mix a full, stable hexadal wave of 6 phases with a half-wave of only 3 phases?
Well, based on what we just established, a half-wave is structurally incomplete. It's an open loop, a broken circle.
Exactly. Introducing it creates a rupture. The text describes this mechanism in terms of homotopy-type theory, which is very high-level, abstract math dealing with continuous paths and loops. But the core concept is quite intuitive.
Right.
You have a perfectly stable system, 6-phase wave.
Right.
You then introduce an unstable asymmetrical element, the 3-phase half-wave. This creates an immediate open end that the system simply cannot tolerate.
So the system is broken at that point. It has a loose wire flapping around. How does it fix itself?
To close that rupture and restore geometric balance, the structure is mechanically forced to generate a new node.
And that new node is?
That new node is a new prime number.
Whoa. Wait, let me make sure I'm getting this. So you're saying prime numbers aren't just these random acts of nature. They aren't just, the annoying numbers that refuse to divide evenly. They're actually the structural result of a mathematical wave trying to repair itself.
According to Dato's half-wave theorem, yes. Adding a half-wave creates a strict structural necessity. The system must create a new anchor point to resolve the asymmetry and close the loop. And that new anchor point functions as a prime. And again, the source claims this is mathematically proven at level 5 rigor. It's not just a poetic guess, it's treated as a topological inevitability.
That completely changes how I picture primes. I've usually thought of them as just these messy numbers that clutter up the otherwise neat number line. But in this view, they are literally the stitches holding the whole fabric of reality together.
Stitches is a fantastic metaphor, or knots. In fact, the sources frequently refer to this exact idea in the context of the Logosphere, or what they call the crystal of numbers.
Yes, let's talk about this crystal concept. It's such a striking image. The text differentiates heavily between composite numbers and prime numbers based entirely on their symmetry.
Right. Try to picture the entire number line not as a straight string, but as a giant, complex, vibrating crystal structure.
Yeah.
Composite numbers, those are the numbers that can be divided cleanly, like 12 or 20, are described as points of resonance. They fit perfectly and smoothly into the hexadal orbit. They have internal rotational symmetry. They are smooth.
They just go with the flow. Like
Well,
if you spin a composite number around, it basically looks the same from different angles. It balances.
Exactly. But prime numbers. The theorem of hexadal genesis defines primes as points of maximum asymmetry.
They are the rebels of the crystal.
They're the hard anchors. The text actually uses group theory to prove this, showing that for any prime number, the stabilizer is identically 0.
Okay, stabilizer is 0. That sounds very profound. But what does that actually mean for us in plain English?
It basically means that if you try to rotate the internal structure of a prime number, it does not line up with itself again until you've gone all the way around a full 360 degrees. It has absolutely no internal symmetry to exploit. It completely refuses to blend in with the surrounding structure.
And is it because they refuse to blend in that they end up creating the actual structure of the crystal?
Yes, precisely. Think about it. If everything in the system were perfectly symmetrical, everything would just effortlessly slide past everything else. You wouldn't have a structure at all. You would just have a mathematical soup.
Right.
Primes provide the necessary friction. They are the rigid skeleton formed specifically by the wave's inability to perfectly align. They are the structural knots that give the entire logosphere its rigid shape.
That suddenly makes a number like 17 or 13 or 5 feel incredibly important. They aren't just math trivia. They are the load-bearing walls of the universe.
And understanding them as load-bearing walls leads to a very practical application detailed in the texts, which is a process called the Dato-Bertrand step.
Now, this is about finding primes, right? Because usually we think of mathematicians hunting for primes, like they're searching for rare diamonds buried in the dirt. We run these massive supercomputers for weeks on end, just brute force testing numbers to see if they divide.
That is the traditional hunter-gatherer approach, yes. We blindly look for them. But Dato strongly argues for what is called a constructive approach. The core idea is, we don't actually need to search for primes in the dark. We can purposefully build them.
Build them? How do you just build a prime number?
The formula provided in the text is C equals P sub K times P sub M. It's a process of structural division. The theory posits that you can take a known core, like our foundational friends 2 or 3, or an existing prime kernel, And you can divide a very specific composite structure in a way that mathematically forces a new prime to pop out.
That sounds almost like splitting an atom. Or, I don't know, squeezing a slippery lemon really hard until a seed shoots out.
It's remarkably similar to that conceptually. You are forcefully manipulating the symmetrical composite structure to isolate and eject the asymmetrical prime kernel. But what's truly revolutionary here is the theorem of bidirectional structural division.
Bidirectional meaning it works in two ways.
Yes. Historically, when mathematicians look for new primes, we always look up. We look outwards towards infinity, constantly searching for larger and larger numbers on the far right edge of the number line.
Because that's where the frontier is. That's where the undiscovered country is.
Correct. But the sources argue that because numbers are a breathing system, a dynamic sphere, not a flat line, we can also look down. We can look inward, deep into the mathematical gap between the core and the outer shell of the number.
So there's a whole unexplored universe inside the numbers themselves, not just out past them.
Exactly. Remember that tiny delta from the stratification formula we talked about at the beginning?
Yeah, the closure gap.
Right. That gap actually expands and contracts. It breathes. By mathematically analyzing that internal breathing, the theory states you can perfectly predict where the next prime node must appear in order to stabilize the rhythm of the system. You don't have to guess and check anymore. The geometry of the structure tells you exactly where the hole is that needs to be plugged.
Man, this breathing metaphor really sticks with me. It completely transforms the number line from a boring ruler into a lung, or some kind of living biological organism.
It perfectly aligns with the entire Logosphere concept. If numbers are fundamentally vibrations, then the whole system has to be dynamic. It is constantly expanding, contracting, taking damage, and stabilizing itself through the forceful creation of primes.
So let's just kind of zoom out for a second and look at the whole picture we've managed to build here today. We started with this basic idea that numbers aren't static labels.
Right. We established that every single number has a nuclear stratification, a heavy core made of 2s and 3s, and an outer shell of distinct harmonics.
Then we realized that the underlying rhythm of the universe is strictly hexadal. Stable waves must have 6 phases, and you cannot cheat that fundamental geometry.
And when you inevitably do try to cheat it by introducing an incomplete 3-phase half wave, you cause a critical structural rupture in the fabric, and the universe solves that rupture by generating a prime number to anchor it.
Which means primes are the necessary asymmetry. They are the critical knots that hold this giant vibrating crystal of numbers together so it doesn't just dissolve into symmetry.
And finally, because we understand this structure, we don't just have to blindly hunt for these knots anymore. We can use the geometry of the core and the shell to actively construct them, looking both upwards to infinity and downwards into the breathing inner gaps of the numbers themselves.
It is a lot to take in. I mean, I'll be completely honest with you. I am never going to look at the number 17 the same way again. It's not just a number anymore. It's a fully saturated node holding its place in a vibrating crystal.
And a simple sine wave isn't just a wavy line on a heart monitor. It's a 6-part geometric cycle that literally dictates the logical structure of existence.
It just feels so biological. Or physical, really. Like, we aren't even talking about abstract math anymore. We're talking about the raw physics of how reality is glued together.
And that is the ultimate overarching argument of these texts. The idea that math isn't just a language we invented to describe reality. It is the physical structure of reality itself. The logosphere theory essentially suggests that we are living inside the math.
And I think that is exactly where I want to leave everyone today. We talked a lot about the logosphere, this concept of a giant, breathing, vibrating mathematical crystal. If every number is a unique vibration and primes are the physical knots that keep the rhythm from falling apart, are we basically just living inside a giant song?
Or perhaps a giant thought. If numbers are true living structures, then the universe itself is functioning as a kind of massive biological computation.
Well, that is definitely something to chew on while you're stuck in traffic or staring blankly at a spreadsheet today. Maybe there's a deeper rhythm in those everyday numbers you just haven't noticed yet.
I'd say look for the 2s and 3s. Once you see them, they are everywhere.
Thanks for diving deep into the source material with us today. We'll catch you in the next vibration.